think you have this first warm-up, but this is the concept of inverses, but it's kind of a complex one. It's called a composition of inverses. Is there a -3/4 for a tangent somewhere on my unit circle? I know tangent's not on my unit circle, but even if we put tangent on the unit circle like we did yesterday, I don't think 3/4 is going to show up, right? Do you remember what the choices were for tangent? We had 0, 1, square root of 3, square root of 3 over 3, and then the negatives of those. I think that was it, wasn't it?
So that they're going on a triangle in this?
Yes. When we did tangent, we said the tangent is undefined here. The tangent here was square root of 3 over 1, or square root of 3. Tangent here, put this over this is 1. This was 1 over square root of 3, which is square root of 3 over 3. This is 0 over 1. And then these are the negatives of those same values. So there's no 3/4 anywhere on here for tangent. So this is one we have to draw. But inverse tangent, okay, I'm going to use the blue unit circle today. And inverse tangent, it says down here, is in which two quadrants on the blue? It says -π/2 to π/2, which means I can only look in these, right? For tangent and sine. Okay, so this question has inverse tangent is negative. So what quadrant do I have to be in? So I'm going to draw in quadrant 4 a triangle with the x-axis. And I'm going to label opposite over adjacent. Opposite is 3 and adjacent to the angle is 4. Which one of those would I put the negative on? The 3, because it went down. Okay. If I do Pythagorean theorem, this time I have the legs and I'm looking for the hypotenuse. So I get 16 plus 9 is 25, square root is 5. Now what am I supposed to do here? This is asking about an angle. I don't really know what the angle measure is, and I don't need to know, because now what am I supposed to do with that angle? Find its cosine. So once I've drawn the triangle, the cosine of that is what? Adjacent over hypotenuse, or 4/5. That was a pretty easy one. You could do that on a quiz. It's just a draw question written in a different way. All right, I don't think you have these two, but can you grab your unit circle real quick? You do have these ones? Okay. So the first one says start at the π/3 and find the regular sign. So up at π/3, the ordered pair, somebody tell me if I got it right. 1/2 and square root of 3 over 2? Okay, so the sign is that guy, right? And then the question becomes, where is the cosine square root of 3 over 2? Once we figured this inside out, now we're doing the second step. So where is the cosine square root of 3 over 2? Positive is back here at π/6. Everybody okay? This is too much Hofbauer. You can't get on the right slide here. Okay, what about this guy? What are you thinking? I'm thinking I'm going to need to draw. Arctangent is in these two quadrants. Where am I going to draw this? Where's it positive? Quadrant 1. Tangent is opposite over adjacent. So 5 goes over here, 12 goes down here, so mine is not drawn to scale. If I do Pythagorean theorem, I get 169, so the square root of that is 13 here. And then it wants the sine, which would be opposite over hypotenuse. So I need the sine of this angle that we just drew. So 5/13. We good? All right, remember, you will not have your colored unit circle. So you have to remember, if I ask you questions in this fourth quadrant, what are you going to call these down here, guys? If I, for example, asked you the arc sine of -1/2, it's down here, but are you going to call it 11 pi over 6? No, 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 no. You're going to call it what? Negative pi over 6. This would be 45 this way, or 45 this way is negative pi over 4, etc. Okay? Just reminding you of that fact. Okay. Now the other possibility, use these a lot in calc. So we're going to do some of these. It's going to just give you a variable. So here's our question. I'm going to pretend it's not explained here and go through it real quick. The sine is a, or a over 1. All of these, when they give you a variable, you can assume are first quadrant angles. So if I draw a triangle and I know the sine is a over 1, this would be opposite over hypotenuse. So I'm going to put opposite and hypotenuse. Now, this is a lot of variables, but we need to find an expression that goes down here. Okay? So this missing leg squared plus, what is the other leg called? On my picture, right here. A squared equals 1 squared. Okay? So I get the leg squared equals, and I could subtract the a squared over to the other side. Whoops. 1 squared minus a squared. Well, what's 1 squared? 1 minus a squared. That's the leg squared. So if I square root both sides, I can't stress this enough because everybody's going to do it at some point. You cannot simplify a radical with a plus or minus. This does not simplify. It is the square root of 1 minus a squared. Okay? Even if you just can't simplify it. You cannot simplify it. So the answer for this missing piece down here is 1 minus a squared. Then they have chosen a really ugly one. They want the tangent. So tangent would be opposite over adjacent. So we have a over the square root of 1 minus a squared, which then they multiplied top and bottom and got this disaster. I'm not going to rewrite that because it's just gross. All right, let's try some. Do you have these two? Okay, so this is saying some angle has a cosine that is x over 1. First quadrant. Where am I going to put the x and where am I going to put the 1?
1 is hypotenuse and then x over 1.
Okay. Now how do I write an expression for this leg over here?
Cosine.
No, I need an expression in terms of x and 1 to write on that leg right there.
1 minus x squared.
Almost. Okay, so x squared plus the leg we're trying to find squared equals 1 squared, right? So we're going to subtract. And we're going to have to square root. I can't simplify that except what? 1 squared is 1. But that's it.
Are we only allowed to do the 1 squared thing because it's 1?
We're not simplifying the 1 squared. We're not square rooting it. It's just the fact that 1 squared is 1. So let me do one with a different number real fast. If it was this triangle and say it had an x here and a 4 here, yes, it would be 16 squared minus, 16, not squared, minus x squared, square rooted. Okay? What if it was this, though? I think we're okay. All right, we'll talk about more as we go. What did we want after we figured out this triangle? This part helped us draw the triangle. We're done with that, and now they want the sine of this angle. So I need opposite over hypotenuse, which would be 1 minus x squared all over 1, or just square root of 1 minus x squared. Yes, no, maybe, so. Okay, I'm gonna put this one on another page. Okay. So this one says we have some triangle in the first quadrant, badly drawn, whose sine is x over 1, or opposite over hypotenuse. So the x goes here and the 1 goes here. So to find this leg, anybody tell me what we're going to do? Squared minus x squared, and then square root, which will simplify to just 1 minus x squared. Not 1 minus x, cannot square root that. And then what do they want us to state? What the cotangent of this is. Okay, so cotangent, instead of opposite over adjacent, is adjacent over opposite. So the expression we're going to get is 1 minus x squared over x. I know these are icky, but you need them for calculus, and that's just Pythagorean theorem with variables. All right, worksheet 21B. Kind of more of the same, or are these the same two? Yeah, well, we'll practice. Where am I going to put the x and the 1 for this one? If the cosine is x over 1. Anybody? If cosine is x over 1, this is adjacent and hypotenuse. So here is the x and here's the 1. What goes on this expression then? The hypotenuse Everybody good? Now it wants the sine.
Sine of that would square root of y minus x squared.
All over the hypotenuse was just 1. Okay. The one on the quiz, can we change this number 2 maybe here? The one on the quiz, I'm going to call this the fixed number 2, actually has two things. It says like maybe b over 2. So there is some angle whose sine is opposite over hypotenuse. So if this is a 2 and this is a b, what would the expression be for the bottom down here? Like squared plus b squared equals 2 squared minus b squared.
Square root of 4 minus b squared.
Yes. Any questions about where we're getting that? Cannot simplify that. Don't do it. And then it wants the tangent. Oh, way to go, Hofbauer. Way to go. What? I don't think I'd ask this on a quiz, but the tangent is opposite over adjacent. So I'd have b over this, which if I multiplied by this, I would end up with b square roots of 4 minus b squared all over 4 minus b squared, which still doesn't simplify. Way to make a disgusting one. It quite likely asks for like cosine or something on the quiz, not tangent with a disgusting one like that. But questions? All right, we're going to practice with our unit circle. Ready? This is just, where's the sine positive square root of 3 over 2 using this unit circle? What do you have to be careful about here? That you're looking at sine, not cosine, right? Where's sine? It's the y one. So where's the y square root of 3 over 2? Pi over 3 is what I got as well. How do we find the tangent of negative 1? What quadrant am I looking in? Yes, negative tan is down here. And remember, the tangent would be negative 1 over square root of 3 here, negative square root of 2 over square root of 2 here, negative square root of 3 over 1 here. So which one of those simplifies to negative 1?
Negative.
That one, right? Square root of 2 over square root of 2. So don't call it 7 pi over 4. You got to call it negative pi over 4. This is just written as a decimal, but where's the cosine negative 0.5? If you don't remember what's happening, can't you just look at, it doesn't happen. There's not a negative x value anywhere over here, right? That's because cosine is these two. Negative 1/2 would be over here at 2 pi over 3. Okay, where's the tangent square root of 3? Anybody tell me that one?
Negative.
It's positive square root of 3 is what they asked for. Yes, because when you put the y over the x, you get square root of 3 for the tangent up there. Okay, now we got a composite one. First, you have to tell me what angle has a cosine of 1, and then once you find that spot, you need to tell me what the sine is. So cosine of 1 happens at 0, right? And then it actually wants the sine there. What is the sine of 0 radians? Sine of 0 radians is also 0. Now, what?
Cosine, what?
It's, wouldn't it, you just.
Is that what your paper says?
Yeah.
Okay.
So, like, wouldn't
It's not,
cosines for both, wouldn't you just, if you 1 over square root of 3, then you just rationalize it?
let's see. Maybe it's gonna, yeah, I think in the first question. So cosine is adjacent over hypotenuse, which is okay because the square root of 3 is like 1.7, so that works. And then they just want the cosine again. So yeah, it's just 1 over square root of 3, which is square root of 3 over 3. I won't ask that weird question. It actually is not from your unit circle, okay? Because the cosine on your unit circle is never square root of 3 over 3. Only the tangent is, right?
Isn't it from the 60/30?
It's actually not. Because on the 30, 60, 90, the square root of 3 would be across from the 60, not the 90. All right, anyway, it was just a weird question. We'll agree to that and move on. The inverse sine, this is definitely a draw. It's positive, so I'm going to put it in the first quadrant. Where am I going to put those numbers? 5, 12 is the sine, so we have,
5 on the side and hypotenuse would be that like
okay. This is not as nice as I thought it was.
wouldn't be that bad.
Because if the 12 was down here, it would be 13, but this is 5 squared plus leg squared equals 12 squared, so minus 5 squared. 144 minus 25 is 119. So then if I square root, I get the square root of 119, which doesn't simplify it. Does not simplify, sorry. And so now what is the cosine of this picture? Adjacent over hypotenuse? That could be on a quiz.
Why? Must it?
Well, I'm hoping you know Pythagorean theorem. All right. This little business where x is greater than 0 just means we're in the first quadrant, and I'm just telling you they're always going to be in the first quadrant when they have an x. Okay, so there's some triangle that this is the hypotenuse, so I'm going to put an x on the y side, essentially, right? Because opposite would be over here. So it's not really an x coordinate, it's just the value of x. It's some unknown. And the hypotenuse is 5. If I do Pythagorean theorem, I have some leg plus x squared equals 5 squared. How is that expression going to look? 25 minus x squared, and then I need to square roots, and it will not simplify. Don't do it. Okay, now it wants the what from that angle? Cosine, which would be adjacent over hypotenuse. So square root of 25 minus x squared all over the hypotenuse is just 5. Do you see where people are going to make a mistake and reduce things they can't reduce? Don't do it. Don't do it. Does not reduce. All right. If you pull out worksheet 22 real quick, I do have a couple more examples in the middle of worksheet 22. Here before, after number 17, it says I should do this example maybe. I feel like we just did these, but I don't know that you have these. Just talk me through this. If I said the cosine was 4/5, where would I put that? Where would the 4 go? And the 5 would go? So 4 squared plus leg squared equals 5 squared. 25 minus 16 is 9. So the leg squared is 9. This leg is 3. So the sine is opposite over hypotenuse. So 3/5 is what we're looking for. This one has a tangent of 2/3. Tangent is opposite over adjacent. So the 2 goes here and the 3 goes here. What am I going to write here? Leg squared plus leg squared equals hypotenuse squared. 9 and 4 is 13. Someone check that out, but is that right? Okay, cosecant is the flip of sine. So it's hypotenuse over opposite. So square root of 13 over 2. Seem okay? The ones with the x's start down at the bottom here. I feel like one of them I did for you. Did I do one on your sheet? Or not? Does it have one worked out? No? Am I making that up?
Number 18.
Is this, I don't know. I have at the bottom, what does the worksheet look like? Does it have
Looks like
on
it's
22 down at the bottom? But did I change the question too?
Yeah, it was arctan 4x.
4x, not 4 over x?
Just 4x.
Okay. So I made it this. And it's still secant though?
Yeah.
All right, so if we had a tangent that was 4x over 1, opposite over adjacent, so we'd have leg squared plus leg squared equals hypotenuse squared. 1 squared, 4x times 4x is 16x squared. Everybody good with that? And again, then when I square root, even though it's a plus, it doesn't matter. The only thing I can simplify is that 1 squared is 1. Otherwise, this stays a very disgusting 1 plus square root of 16, or 1 plus 16 squared, all under a radical. Then it wants the secant, which thankfully is hypotenuse over what? So it's just the square root of 1 plus 16x squared over 1. Is that one finished for you or not?
You just had to write that.
Okay, so you just had to give me the answer. I drew it all for you. All right. Better? That's to help you with D, I think, then. Should give you a hint. Okay, please work on worksheet 22. Let me know if you have a question.